And our new logo is up there. So XSS attacks, those are bad. Anywhere that you have input that you collect from on a website, you can have an XSS attack. And XSS stands for cross-site scripting, which means you're not looking at code that's necessarily executed on your website. You're looking at code that's on an external website that then is interacting with your own website. So that's what we're looking for as dangerous. There's several different kinds of attack. They fall into three categories. Mostly, it's a growing field in the dangerous world of website attackers, but stored attacks are when raw input is entered into a database and then displayed on your website. So think of a comment form or let's see, maybe a review of a product on your e-commerce store. So that's pretty common. That's the one that most people associate with that type, with an XSS attack, is that type of attack where it's stored in a database, not properly sanitized, and then when it shows up on the website, it does something to the browser, to the user, or to the website. A more obscure attack is a reflected attack. That's when you do something on the website that, again, collects input, but then can send something like an email out. Or if you attack somebody that's on, say, the Facebook fan page for a business, and you put in a link, and I'll go through a couple of examples of what happens there. And then, again, you can infect them in the same way, doing the same type of attack. And the third type is DOM-based, which if you guys have messed around much with Chrome developer tools or with Firefox's Firebug add-on, you know that you can mess with the actual HTML and JavaScript that's on the page, and then in some instances you can make that actually go into an AJAX heartbeat type thing, where, you know, WordPress has a thing where it's in the admin, it's always doing something, checking for things to do, and lots of other programs do something similar. So yeah, we'll go into an example of that here in a second. So let's talk about a stored attack. You're running a website and you happen to store some login info in your cookies. So normally when you think about a cookie, you hope that no one else is going to be able to get that, just the actual person saved to their local computer. So what the bad guy does is they write some code and put it up on their website, where it collects from a get variable or a post, usually a get variable, and then saves it into a database where they can then try to attack the website, your website, later. The bad guy then goes to your blog, submits a comment form with a generic statement, but after that has some JavaScript that executes. And basically all that does is it does a redirect to their website with the get variable attached with all the cookies for that user. The database doesn't properly sanitize that script, doesn't remove the scripting variables, displays it on the page. Next person that comes to the page, if they're a user that has any kind of admin access or anything like that, the bad guy then has that access and can, you know, attack your website. So that's pretty bad. Another type is a reflective attack, which we talked about, could be email-based or something like that. So similar to a comment post or a review, let's say that you have a search engine, and what you do is you display the last search on the screen, you know, in plain text. A lot of places do that. Say, you know, you just searched for Doctor Who dolls. So what the bad guy does is something similar. He again submits, actually this is a little bit different. So he finds some of your contact info for one of your customers, say on your Facebook page, and gets a URL shortener or just a really long link that they don't happen to look at, And when they click through, it does something similar. It puts the JavaScript into the page and again executes it. And end result is the same. Bad guys now have login information to get into your website. A DOM-based attack would be if someone is taking over, like I said, an Ajax heartbeat type thing, and is inputting that into either local storage or IndexedDB, or any type of Ajax post request, like for WordPress developers, the admin ajax.php is a common attack point, which is why you see so many WordPress plugins that get attacked. And then, of course, anything that is pulling from inner HTML and then posting it to your database, which, I mean, most developers that have any experience in security probably wouldn't do that, but if you're not thinking real hard about what you're doing, you could certainly do that. Good example, I've just been working on a website where I'm lazy loading a animated GIF as you scroll down the page. If someone were to go in and edit the variable that the JavaScript uses to determine where that image that then appears. So I have a JPEG that appears first as you scroll into view, and then switches that to the animated GIF. That way the GIF isn't playing until they actually reach it. So in this situation, if they changed that variable in the DOM and got there and my code didn't properly clean it, they could then execute some JavaScript and do something similar like steal cookies. So I mean, stealing cookies, that doesn't sound that dangerous really, but there's a lot of different things you can do with an XSS attack. The most dangerous one you hear about is Trojan Horse because it sounds so scary. But anytime that they do something to your website, it can be potentially damaging to your brand, to your company. There are people that do things like add pornographic images to every image tag on your website. There are like I say here, you could modify a press release, which would be potentially fairly dangerous and really change the tone of your press release. Or even worse, you could kill people with changing the pharmaceutical information of what the proper dosage would be. And they're happening all the time. WordPress is a common factor because WordPress is just so everywhere, but it's happening amongst every web-based software. If you're keeping up with GitHub updates or any software update that's web-based, you'll see that they, just about every time they do a major release, they have something to do with XSS attacks and updating their security to cover various situations. There's been millions of websites that have been affected with one single plugin. Supercache had a problem in WordPress. One of the major theme forest templates have had problems. So it's definitely something to keep an eye on if you're a developer working in anything that's web-based. So, I mean, what can we do about that? I mean, you hear about this and you say, okay, that's really sucky, Josh, but what can we really do about this? First step, if you're a developer, you're like, oh, I'll just fix it. Oh, it's my code. If there's a problem, I'll fix it. Well, that's not very much fun. Because, if you're coming at it from a reactive standpoint, it's always going to be hard to catch up with the guy that's already 2 steps ahead of you, is already attacking your website. Yeah, we can sanitize all of our input. We should be anyway, especially if we're inputting it into a database and we know it's going to appear in the front end. And we can definitely keep active in our development community, come to PHP groups and hear security talks. That's great. Or we can not use WordPress, which I don't know about your guys, but I can't get away from it. I've probably got 30 WordPress sites running right now. So there's got to be some way that we can just, say, okay, XSS, that's great, but I'm not going to even have to think about this. And the way we do that is with a special header called Content Security Policy. Now, first up, I'm going to show you how to do it in htaccess, which if you're using Apache or light speed, definitely probably the most effective way to get it into everything on your domain. I'm also going to show you how to do that in PHP in a second, which is a little bit harder because you have to make sure it gets into your main initialization file, but it's 2017. Probably everybody's got an initialization file in their PHP anyway, so it should be fine. So let's look at the syntax a little bit here. You don't have to have the if the module mod headers exist, but why not, right? Because if it doesn't, it might throw a temporary error that knocks your website down until you remove this variable. So definitely add that. What it does is that section after the script source, you tell it what it can execute. It's a whitelist feature. So problems with this, of course, is if you're just whitelisting your site, what about things you embed in your site? Like, say you have a CDN that you're loading your images from. So you got to add those too. You might think that you say, okay, I just have a one line for each of the websites, but actually what you do is you just make one long line with a space in between rather than a tab or anything else. This is one of those cases where spaces wins in the space versus tabs debate. So common, probably YouTube, maybe not Vimeo. We use Vimeo a lot at my work. Google for Google Analytics. And anything else that you're using like a CDN, you would want to add to there. Another gotcha to watch out when you're adding a content security policy is that all of your inline JavaScript will go away, because that's one of the features of this particular header that thinks that inline JavaScript is pretty bad. So anytime you have a script tag within your body, it's going to eliminate that. You probably shouldn't be doing that anyway, just because it is an attack vector. But if you can't get away from it, there is an option that you can add called unsafe-inline. It has to be within a quotes, whereas the rest of the domains that you add do not. So that is another option. Another thing is if you're doing JavaScript eval, which like PHP evals are pretty dangerous, and anytime that you get hacked, you should probably be doing a grep for your evals in your code anyway. It's pretty dangerous. But if you have it, like Facebook has it, they have this particular variable in their content security policy. You can add it, and it's similar. It has to have it be in quotes as well, and it's called unsafe-eval. Besides that particular powerful one, content security policy, there are some additional headers that you should probably be aware of. X-frame options is the one that you can add that keeps people from being able to put your website into an iframe. So that's pretty nice. I actually have a newsreader that depends on people not having that variable in their website, because I iframe all these different blogs that I like to keep track of. So if everybody adds this, it's going to be a problem for me. I'll have to find out some other way to get that content. Strict transport security. If you already have something that makes your website be all HTTPS all the time, all SSL all the time, you can add this as just an additional option on the server side that will make sure that your website always fires in HTTPS. The content type options. To tell you the truth, I don't really understand this one extremely well. Somebody else that knows a lot about MIME sniffing might know what that particular attack vector is. I think it has to do with making sure that things that are on your website execute as if they are. So an image can't be executed as PHP, PHP can't be executed as an image. If you're inside an image tag, you can't have a PHP as a source. I think that's what that's going on about, but you might want to look into that more if you're extremely interested in that one. I just go with the default setting that they recommend, which is no sniff. XSS protection is another good one. It is not as powerful as content security policy, but you should definitely add it. And its default option is 1:mode equals block. So putting all that together, we have this particular string of loveliness. Under X-frame options, we have deny. We can also have another option, which I'll go into in a second for showing if you iframe yourself, which I guess you could do that. I don't know why you would. Maybe for a particular image, like JW Player, perhaps. There we go. So PHP, they have the header function, which is similar to the set header in htaccess. And you would need to go into wherever your initialization file is and set up all these in the same format as what you saw before, except in PHP's syntax. So the same thing as what you saw on the last slide, but in PHP. Oh, I should mention, same origin is what you add if you want to iframe yourself rather than deny. And now for the fun part, if you want to get on your phones and pick your favorite website, securityheaders.io, and I would recommend that you tick the checkbox for not showing this on their website, because I didn't on Public Strategies, and we had 800 hits in the next hour from Belarus. So I think if we got a big fat F, by the way, and it's simple to fix. You just go into your initialization file, add those functions, and boom, you got an A. So any website that you have any concern about your users or people being able to get into your admin, especially if it's an e-commerce site or any WordPress site that has WooCommerce installed or anything e-commerce related, I would definitely test your websites and run it. Anybody get an A? Anybody? You type in a URL for any website into the box and then submit. Let's see what you get. And it will tell you which ones you're missing and what you can do to add them, which is kind of nice. And that's XSS security, guys. Nipping it right in the bud from the beginning. Any questions? Hopefully I can answer. All right, thanks.